Welcome to week 3, lecture 3, concept of load training 3. Objective of lecture 3 is to recall health specific fitness variable. The second objective is to describe the sport specific fitness variable training load. Here we will apply training load concept to describe sport specific fitness variable. And the last objective is to apply interrelation between the types of training load to describe sport specific fitness variables. Outcome of lecture 3 is you should be able to demonstrate to use training load concept for sport specific fitness variable as well as write training load concept to describe sport specific fitness variable. Let's begin by recollecting sport specific fitness variable. So what type of fitness comes under sport specific fitness variables? These are cardio fitness, power fitness, speed fitness, agility and quickness fitness, conditioning fitness, coordination and balance fitness. Now recollect, we are trying to describe the training load, which include frequency, intensity and volume. To specifically, we are using intensity and volume, which is termed as work done, to describe sport specific fitness variable. Let's begin with cardio fitness. Here there is an overlapping of using intensity with respect to health specific fitness variable, with a difference of an additional describing the person HRR at BLT1, BLT1 and BLT2 or greater than BLT2. So we will explore what BLT1 is in the upcoming slides. Volume as well will overlap to describing cardio fitness to improve health specific fitness variable. Let's begin by describing cardio intensity to improve sport specific fitness variable. The same table can be used to describe cardio fitness to improve the sporting activity. The only difference is because sporting activity demands a very high intensity, an athlete is required to have a high level of cardio fitness. Hence, if you are aiming to improve the cardio fitness of an athlete, the intensity would always go in between vigorous to near maximal or maximal. Let's describe intensity to improve cardio for an athlete using percent HRR at BLT1 or BLT2. Let's begin by knowing what BLT stands for. It stands for blood lactate threshold. From an athlete's point of view, it is a training intensity where your body starts to use anaerobic system to supply energy for the working muscle. Do not get confused here with cardio being considered as a continuous activity. Every sporting activity is done at an interval level, but it is done at a prolonged duration. So you should be having an ability to perform it at an interval level where your blood lactate threshold, your anaerobic system is challenged, and it becomes important that you improve this energy system to improve your cardio fitness. From a scientific point of view, blood lactate threshold can be defined as a sudden rise in blood lactate concentration as the training intensity increases. Let's relate it with an example. You have prescribed a weekly workout to improve your cardio fitness, where the frequency is 2 times, the volume is 20 minutes per workout, you do 1 sets. Let's assume the baseline of your blood lactate threshold has come to be around 70% of HRR and blood lactate threshold has come to be around 85% of HRR. Now this is calculated separately before the training routine starts, which is considered as a fitness stress assessment. To relate blood lactate threshold at 70% of HRR, you need to be aware that now blood lactate threshold 1 at 70% of HRR means that as my exercise intensity increases, my blood lactate threshold, my blood lactate starts to increase suddenly exponentially at 70% of my HRR. And then there is a linear increasing in the blood lactate as the intensity increases, and there is a second point during the exercise intensity where my blood lactate increases much more non-linearly. That point is called as blood lactate threshold 2, which in this case has come around at 85% of the exercise intensity. Now, higher the blood lactate threshold tolerance at higher intensity, the better the athlete is able to perform a sporting activity at a higher intensity. And this is what is ultimately required. You want your athlete to do the sporting activity at much higher intensity. So how do you relate? This is the baseline. So you want to improve this baseline, and you prescribed an intensity to train at blood lactate threshold by writing 70% of HRR to 80% of HRR. Now this comes to be around vigorous intensity. So in compared to improving your cardio fitness for a non-athlete, for an athlete, apart from knowing that you are doing an exercise intensity at vigorous level, you also have to use a parameter of blood lactate threshold and train at vigorous intensity. Such kind of training is also called as tempo training or threshold training. So this is how improving your cardio fitness for sports specific fitness for an athlete differs with that of a non-athlete. Let's take another example where you want to improve your blood lactate threshold 2. In this case, now you prescribe an intensity at 85% to 95% of HRR. So you have a baseline and you give a little higher baseline than your blood lactate threshold. So you are actually training at blood lactate threshold 2 and greater intensity of blood lactate threshold with an aim to improve this baseline level. For that, you use a short HIIT type of training. Now, when you say an HIIT, when you say an interval training, it has a work interval and it has a rest interval. Now, let's see how you describe this type of interval training in the volume in next slide. Volume is similarly described as shown in the lecture 2, where sets duration or sets or distance can be used, or exercise sets or duration can be used. Let's see how it differs when you try to improve the cardio fitness of an athlete. In this example, the type of stimulation given is short HIIT. As mentioned earlier, when you say interval training, you have a work interval and you have a rest interval. Now you plan to improve your blood lactate threshold 2, where you gave a prescription of work interval to train at 85% to 95% of blood lactate threshold and the rest interval at 70 to 75% of HRR. So how do you write a volume when you use a short HIIT type of training, a cardio training? Your work interval is 30 seconds and rest interval is 30 seconds. So work and rest interval together, it means 1 minute. And this work and rest interval together is called as one series. So I plan to do for 10 minutes. So totally I have to do 10 series and I do it 3 times a week. So a total of 30 minutes. So the description is somewhat similar, but with an addition of short HIIT, you have to add the series in the volume. That's how the workout to improve a cardio fitness for an athlete can differ from a non-athlete cardio fitness. Now let's see an example, interrelationship between different types of training load. Here, a 3 weeks workout to improve cardio fitness is given. In week 1, we have given a stimulation by the variation. So a new type of variation is introduced in week 1. Let's say it's short HIIT. The prescription is with respect to intensity, I train at 85 to 95% of HRR at blood lactate threshold 2 and I train a total of 10 minutes. Now this is a stimulation that I am giving. So this stimulation will follow the gas principle, where I would experience a resistance phase, which is an opportunity that I give to have an adaptation in my body and thereby improve my baseline level. Now what happens if I do not consider stimulation load? I do not consider training load concept. I do not watch what is the frequency, intensity or volume I have prescribed for my workout. In that case, I may end up giving a same type of load or a greater load. In this example, let's say in week 2, I have not given any kind of stimulation. So using an interrelationship between the type of training load, this stimulation load will now become a retaining load. And if I continue in a similar manner, that is in week 3, I still do not give a stimulation load, this retaining load would now become a detraining load. So what exactly has happened is, the adaptation that I have achieved by giving a stimulation in week 1, by the time I go in week 3, the baseline that new is been created, it may still be same or it may drop down. And this is not you are looking for. The very reason why you have started training is to get a new baseline. So this is an example that will give you an understanding. If you are not monitoring the weekly training load, you will eventually end up detraining, giving a detraining load as you go from week 1 to week 2 and from week 2 and week 3. You may assume that, or you may have an understanding that you are actually doing an exercise, but ultimately that exercise training load is becoming a detraining load, and the new baseline that is achieved goes down to the previous baseline. Now let's start with second sport specific fitness variable, power fitness, and describe the intensity. A power intensity can be described by velocity of movement. Now recollecting the person-based training method which we use to prescribe muscular strength training, velocity-based training is an alternative method which overcomes all the drawbacks of person-based training. So in this method, the power training is divided into different velocities, which is described as strength speed. In strength speed, you focus of lifting moderate to light load, and you move that load with a moderate velocity, and the range of the velocity is in between 0.75 to 1 meter per second. In speed strength, you use light load, but you move that light load in much more higher velocity. The range of the velocity given is 1 to 1.5 meter per second. Then the third type of power training is where you do not use any external load. You use your only body weight, but the velocity of the movement is very high. It is with equal to or greater than 1.5 meter per second. Now let's relate with an example. Now, in the example, I plan to improve my power by training it 2 times a week. The type of training I am using is starting strength. The progression that I am giving is greater box height. The volume is I do every exercise 3 sets 4 repetition. And the intensity that I prescribe is to maintain the movement velocity of every exercise greater than 1.5 meter per second. Now this type of training is actually a plyometric training. Now let's describe power training with respect to volume. Volume is again described in a similar manner to that of the cardio fitness or to that of a resistance training fitness, with the difference that instead of using distance and duration in a cardio fitness, you use only repetition. And another exceptional use is the describing the volume in terms of cluster sets. As your power training advances, you try to do more number of repetition. So when there are more number of repetition, the aim of every repetition is to maintain the high velocity or to maintain the velocity that is being prescribed. So in order to do that, a cluster set method is used. Let's describe the cluster set with an example. Let's start by example number 1, where you describe the volume without using the cluster set. In a given example, I have prescribed 4 exercises of plyometric. I do 3 times every exercise, 3 sets of every exercise, and I do every exercise for 4 repetition. So the volume of sets per workout is 12. And since I am doing it 2 times, the total volume is 24 sets. A similar way of describing volume to that of a resistance training. But when you advances your power training, in this example, you improve from 4 repetition to 8 repetition. But however, you do not have a capacity to maintain the given intensity of plyometrics greater than 1.5 for more than 2 repetition. So what you do, you use a cluster set method. You aim to do a total of 8 repetition for every exercise for every sets. But you do not have a capacity of maintaining this prescribed velocity more than 2 reps. So using the format of cluster set, a total of 8 reps, you do 2 reps per cluster to maintain the given intensity. And because you do total of 8 reps, there are total of 4 clusters that you do. And in between every repetition, you wait, in between every cluster, you wait for 10 seconds. So you do 2 repetition, you wait for 10 seconds, and you repeat this way for 4 times. That completes set 1. This is yet another way of describing volume for a power training, specifically when your power training is in an advanced mode. Now let's understand the interrelationship between types of training load with another sets of fitness variable. In this case, a 1 month power workout routine is given, where the stimulation is given each week. Now what would happen if I give stimulation each week with a very high volume of workout? Week 1, I am giving a stimulation load, so the body is going to follow a response of having a resistance phase where recovery would take place, and then come up to have a new baseline by having a super compensation phase. So in week 1, I can expect that I can have a little higher baseline with respect to my power fitness. In week 2, again I give a stimulation load. In week 3, again I give a stimulation load. In week 4, again I give a stimulation load. So with this pattern of designing a stimulation load or sequencing a stimulation load, I am not giving my body opportunity to come above the resistance phase. And if it is continued for a longer period of time, this stimulation load would become a detraining load. So again, in this case, you may think that I am giving a stimulation week by week, session by session, but because you are not allowing an optimal recovery, you would still end up by having a baseline fitness level which is much more less in compared to week 1, or in worst case scenario, you may also experience certain overtraining syndromes. So in summary, describing your weekly training loads help in making an optimal decision to select a stimulation load. In absence of writing the weekly training load for a given fitness training routine, you may lead to choose a submaximal sequence of stimulation and retaining load, or in worst case scenario, you may also lead to an overtraining. Thank you.